a voice diary.
So one thing we've noticed in all our research is a clinical participant is really looking for help with whatever they're going through. So they want a solution out of all this. They want to help like the research to come out with something at the end of the day. So while there are privacy issues obviously related with this, it does not come from like users' perspective. Like they really want to share their data because they want others to not go through this. So we do not record like raw audio. We're sensing conversations, and that is like one part of signals we use. But this audio diary is something they can submit. It's optional. It's completely optional. And you can still see that we got like 4,809 over 30 days, right? They're really motivated to do this. They were not paid for submitting the audio diary, but they still did this, which was, yeah, I don't know. Yeah, okay, thank you.
Thank you. Let's speak again. Okay, the next one is detecting social context from mobile sensing. This is another to analyze different modalities like a PPG, audio, EDA. Yeah, so how to do that? Okay, so the next speaker is Zhiyuan Wang from Virginia University. So you may start.
Thank you. Yeah, thank you for your introduction. Hello, everyone. This is Zhiyuan Wang from the University of Virginia. I'm presenting our paper, Detecting Social Context from Mobile Sensing Indicators in Virtual Interaction with Socially Anxious Individuals. So social anxiety disorder is super significant, which affects 13% of US adults, with 80% of them do not seek treatment during their lifetime. Even when they do, they delay about 16 years. So digital mental health solutions are promising to address this gap given their pervasive and the accessible nature. But generally, it works in the loop of detection and interventions. The factors might be detected include, for example, are people feeling anxious or are people engaging in the interventions very well to inform more like when to give the interventions. But against this background, we argue that detecting the anxiety-relevant context is super important to inform how the interventions or what kind of interventions to deliver according to people's situations. So this paper is the first step towards context-sensitive, or people more likely to see it, context-aware, just-in-time adaptive interventions for state anxiety disorder. So let's talk about the detection, contact detection in UbiComp community. So there is a long history of contact detection in UbiComp. So what are the contexts people would like to detect it? So something like mental health outcomes, anxiety, depression, and stress, and also human activities, daily life contacts, and transportation ways such as people in a car or in a plane or in a bag. But that's all not the context we want to detect in our context. So in our context, we just want to study can mobile sensing indicators to identify state anxiety relevant social contexts. So what contexts are we designed? To achieve this goal, we organize a highly controlled online virtual social interactions because of the COVID-19 with socially anxious individuals gathered in Zooms with belt strap E4 on the wrist. So the first context we want to study is the size of social group. So are people staying alone, or they are in a dyadic conversations or in a group meeting? So in our case, we just said 6 people in a group meeting. And to manipulate the degree of social evaluation, we call them explicit evaluative and not explicitly evaluative. So we set another set of dyadic and group meetings. But in this kind of group meetings, we will tell the participants, you will be rated by your conversation partners after this kind of events. So they may have a kind of a stressor or fear of being evaluated, and they may have different kind of physiological responses. And also, we manipulated the temporal phase of anxiety. So before each event, we will tell them, you will have a kind of a conversation like this, and please vividly think about these upcoming events. And then people will go into a session communicating with others. And then after each sessions, we also require them to vividly think about what just happened, to have a kind of a capture of their post-event responses. And here are some details about data collection. We recruited 46 participants with moderate or high in treat anxiety symptoms. And we put them into the, as I mentioned, the five the 5 events in the Zoom sessions in about 2 hours. So here is a time series of kind of sensing recordings of participants. So you can see she or he just experienced 5 different kind of social events with non-social and social. And for the social, they have 2 different kind of set of settings. And we collect the multimodal data, biobehavioral data, and finally get the features from empathic E4, which include PPG sensor to measure heart rate variability, EDA sensor to measure skin conductance, and accelerometer sensors to measure the waist movement and skin temperature sensor. And we also have Zoom recording, so we can just kind of have a secondary analysis of the audio signals, but it's not our main objective in this work. So let's observe the physiological responses across the designed social settings. So in non-social versus social, we can see social situations stimulates the physiological responses of the participants, but excluding the skin temperature, we found no differences between social versus non-social. And across the 5 manipulated events, we found that in group settings, interestingly, people have higher heart rate variability, higher skin conductance, but they have lower wrist movement because maybe because people in dyadic conversations are more active in body movement or something like this. So based on this kind of situations we observed, we propose a social contact detection pipeline based on machine learning techniques. So for any segments we got from the sensing readings, so we featurize them for PPG sensors, EDA sensors, and something like this. And then under leave 1 participants of cross-validation strategies, we do feature selection, model training, and model testing for predicting different kind of social contact tasks we designed. So here is the results. So here we can see a overall map of the 15 social situations we recorded. And we use the balanced accuracy for fair model evaluation across unbalanced data sets. So here we only use the empathic E4 sensor features, and if we just design the task as detecting people are about to social or non-social, we can have a 78% of accuracy. And we design the task as, can we detect our people are actively in a conversation? We can achieve, by only using this physiological data, achieve 74 accuracy. And if we do 3 classification for pre-concurrent post-event, we can get 58. And for a long dyadic versus group meeting, we can achieve 54. And it's kind of limited to detect the social evaluation, and later I will tell more about the social evaluation part. So also we studied the potential of audio signals. So given that in these 4 situations, we can record people's active conversations recording, so we also extract features from there. And you can see in these 4 situations, we just defined 2 different social contact detection tasks, dyadic versus group meeting, and non-evaluative versus evaluative. So we can see with only biosensors in biostrap, we can achieve the performance around the baseline, and for the social evaluation, we cannot beat the baseline at all. But after getting audio features, it boosts the model performance to another level. So it just shows us the audio is super valuable in this specific task. And also kind of incorporating biobehaviorals and the audio behaviorals kind of give us more higher accuracy kind of. So, and also in short, we found that each sensor contribute differently to different tasks, and due to the time limitation, I just quickly go through it. And we found that PPG heart rate variability features are super valuable consistently, and also EDA tonic relative features and accelerometer magnitude features are super interesting. And we also tried to personalize the Zhiyuan participants out models by fine-tuning the model with a small number of observations from the specific tested individual. We found that simple wide models get significant shifted to a better performance level by just doing personalization. So finally, let's come to the day discussion. So we did some good job in some kinds of social context detection tasks in this paper, and also there are some limitations. For example, we didn't did well in social evaluation, maybe limited by our study design because we just told the participants you will be rated, but who cares maybe? Yeah, so that might be the problem. But yeah, so that's also our future work, and fortunately we got a chance that audio can give us more information to infer the social context, so that's also kind of our future work. But we have to acknowledge that there are some privacy issues with audio, so we are just developing some privacy-preserving techniques to handle the audio problem. And we also found that PPG heart rate variability is super interesting, and the takeaway for us is we do not need to buy super expensive biostrap Empatica E4 in the future study. We just maybe have a Samsung smartwatch or Apple smartwatch can be enough. And we need personalized models because there are super strong individual differences, and definitely the next step is from the lab study. So this is a control lab study, but in the future we will do more in large-scale interval study. And just to mention that our final objective is to propose or develop a context-sensitive just-in-time system for social anxiety. Thank you, guys.
Thank you. So we have time for a short question. Oh, yes? Please go ahead. No? Okay.
Hello. Hi, Pablo Paredes. Thank you for your presentation. So why not just use audio? I mean, it's social, people talk. You're trying to detect when there's no verbal cues. Like, I'm not entirely clear why you need Empatica if you can just listen to people talking, right?
Oh, yeah.
If they are talking, they're socializing. So can you explain the use of Empatica? Because first, there's not a strong signal. And the second question is, did you counterbalance all those conditions, or you just use the same order every single time for every experiment?
You mean, oh, yeah.
Yeah, did you change the order?
Yeah, sure. Okay, so first let me answer the first question. So why do not use audio here is that audio we have some concerns for our audio. For example, we cannot always continuously collect audio during your daily life because it's kind of some third-party policies or, and also super costly to collect audio. So
but it's expensive to wear Empaticas
too.
Very expensive.
Yeah, sure. And we just want to see if the pervasive wearable sensor can help us do this. And finally, it's kind of cheaper or more accessible to everyone. Yeah, so that is the first question. And the second question is yes. So for the convenience, I just present that there are the 4 social sessions in same order. But in our studies, because the participants are gathered in different subgroups. For example, 6 participants are in a group, and our RA organized them into the study, and their social sessions are shuffled.
Okay.
Yeah.
All right.
So
Thank
to
you.
avoid that, they already know each other, and then come to the evaluation part, they do not care. Yeah.
Okay.
Thank you. Mm-hmm.
Okay. Let's thank the speaker again. Okay.
Main screen. No, I think it went to other screen.